During the Second World War, a quiet but astonishing clash unfolded far from the front lines, away from the thunder of artillery and the roar of engines. A clash not between armies but between philosophies, industries, and the very way nations imagined war. And nowhere was this contrast more dramatic than in the reactions of German engineers when they first encountered, examined, and dissected American tanks, especially the M4 Sherman, a machine that embodied the industrial soul of the United States. And when those German specialists, trained in a culture that prized precision craftsmanship above all else, finally got their hands on captured American vehicles and the reports describing how they had been built, maintained, and deployed, many of them found themselves stunned in ways that defied everything they had believed about warfare, engineering, and the future of mechanized combat. To understand why their reaction was so intense, one must first picture the German engineering mindset of the era. German industry, influenced by decades of tradition and a deep cultural attachment to perfecting every component, often treated tanks not simply as weapons, but as individualized masterpieces, machines shaped by careful, deliberate craftsmanship, with complex transmissions, thick armor plates formed by expensive machining, finely tuned engines that required constant maintenance, and design principles centered around technical superiority, even if that superiority came with an enormous cost in time, labor, resources, complexity, and battlefield practicality. This was the mentality that produced formidable machines like the Tiger and Panther, tanks that could dominate in single combat, but which demanded almost obsessive upkeep and which could never be produced in sufficient numbers to match the scale of the war they were being built to fight. On the other side, across the Atlantic, the United States approached the problem with an entirely different philosophy rooted not in artisanal detail but in industrial power, efficiency, and standardization. American engineers designed tanks the same way they designed automobiles and tractors: fast to build, easy to repair, rugged enough to survive terrible conditions but simple enough to keep running with basic tools, spare parts, and soldiers who had never turned a wrench before joining the army. And this clash of philosophies, German precision versus American practicality, set the stage for the moment when German engineers first realized what they were truly up against. The story becomes even more dramatic when one considers the numbers. While Germany struggled to produce a few dozen heavy tanks per month, the United States was manufacturing hundreds and hundreds of Shermans at plants like the Detroit Arsenal, a factory built by Chrysler in only months, and designed specifically to churn out armored vehicles the way Detroit had once produced cars, using conveyor belts, stamping machines, interchangeable parts, and an army of workers who became tank builders almost overnight. This scale alone was something that shocked the Germans, because in their minds, tanks were too complex to be mass-produced in such astounding quantities. Yet the Americans made it look effortless, delivering more tanks each month than German industry could produce in an entire year. And this sheer volume meant that while German tank crews drove into battle in rare and precious machines, American crews rode into the same firestorms in vehicles that could be replaced almost indefinitely, a factor that altered not just battles, but the entire strategic balance of the war. But numbers were only part of the shock. The real astonishment came when German engineers inspected Shermans that had survived unimaginable punishment and kept fighting. Machines that were not elegant or refined but astonishingly tough, adaptable, and reliable. And one of the most famous examples of this came in 1943, when German specialists examined a captured M4 that had traveled more than 5,000 miles in brutal desert combat in North Africa, under sandstorms, enemy fire, constant movement, and minimal maintenance. And yet the tank still ran without major mechanical failure. This, to the Germans, seemed almost unbelievable, because their own tanks, especially heavy models, often broke down after only a few hundred miles if not maintained constantly. And the idea that a mass-produced American tank could survive such abuse was something that many German engineers initially dismissed as exaggerated until they examined the machine with their own hands and realized the reports were true. What shocked them the most was the simplicity. American tanks used straightforward mechanical systems, wide tracks that performed well in mud and sand, engines derived from aircraft or commercial applications that were designed for reliability rather than sophistication, transmissions that did not require mechanical genius to repair, and modular parts that could be swapped in minutes rather than hours. Everything was built with the assumption that, in war, machines must be repaired quickly because battles did not wait for careful adjustments. So every Sherman was not a perfect machine, but a practical one. A weapon that combined reasonable armor, acceptable firepower, and unmatched logistical convenience. Something the Germans could not fully replicate because their industrial infrastructure was fragmented, bombed relentlessly, and not built around the idea of near-limitless mass production. German engineers were equally surprised by the way the Americans integrated logistics into their entire design philosophy. Because unlike the German army, which often relied on a patchwork of specialized parts for each model, the U.S. Army demanded interchangeability across entire production lines, meaning spare parts, tools, fuel types, and repair procedures were standardized, allowing American mechanics to fix tanks on the battlefield in mere minutes or hours. While German vehicles often required specialized parts that were difficult to replace due to Allied bombing and transportation shortages, this logistical advantage meant that even when American tanks were destroyed or damaged, they could be replaced or repaired quickly. And this truth became painfully clear to German officers on the Eastern Front and in Normandy, where they observed that every time they destroyed a Sherman, two more seemed to appear the next day. An endless stream of armor that made German victories feel hollow and temporary. For no matter how skilled their crews or how superior their optics or guns might be, they could not kill tanks faster than America could build them. Another factor that stunned the Germans was the speed with which the American industrial system adapted. Because when the war began, the United States had almost no modern tanks and very little experience building them. Yet within 2 years, American factories were producing more tanks, trucks, jeeps, half-tracks, and armored vehicles than the entire Axis combined. A transformation the Germans had believed impossible. For they assumed that massive industrial shifts required decades, not mere months. And they did not fully understand the power of American assembly line culture until it was too late. Furthermore, when German engineers disassembled Shermans, they often found that components were intentionally built in a way that tolerated imperfections, meaning a part did not need to be perfectly machined to fit. It simply needed to meet broad tolerances, something that horrified precision-obsessed German machinists, yet impressed them from a wartime standpoint, because it meant that American factories could use interchangeable labor, rapid machining, and mass stamping without worrying whether every bolt aligned with microscopic precision. And this revelation forced some German officers to conclude that Germany had misunderstood the nature of modern war by focusing too much on perfection and not enough on speed, volume, and durability. Meanwhile, American tank factories kept improving their output, while German plants remained bottlenecked by manual processes, shortages, and the devastating effects of Allied bombing. And as the war dragged on, the gap in production became impossible to ignore. American tank losses in North Africa, Italy, and Normandy were high at times, but they were sustainable because replacements kept coming. While German losses, even if relatively lower, became catastrophic because they could not replace their tanks at the necessary rate, leaving experienced crews stranded without machines to fight in, and forcing the German army to rely increasingly on improvised defenses, outdated equipment, and desperate measures. The dramatic contrast also influenced morale, because German troops were painfully aware that every Tiger or Panther was irreplaceable, a machine whose loss was felt throughout an entire battalion, while American tank crews knew that even if their Sherman was destroyed, another one would be waiting for them the next day. a psychological advantage that affected decisions on the battlefield, willingness to take risks, and the overall momentum of armored operations. German engineers, studying captured Shermans, could not escape the realization that American tanks were designed not as heroic, singular masterpieces, but as disposable tools in a massive industrial war. And this realization clashed horribly with the deeply ingrained German belief in engineering superiority as the path to victory. Instead, the Americans had shown that victory belonged not to the nation with the most perfect machine, but to the nation with the most sustainable machine, supported by a river of spare parts, gasoline, mechanics, railways, and workers who kept the assembly lines humming day and night. Even the interior design of Shermans baffled German crews. American tanks were built with crew comfort and workflow in mind, giving more space, better ergonomics, and simpler controls, while many German tanks, though finely engineered, were cramped, hot, and difficult to operate, sometimes requiring intense physical strength to steer or reload. Whereas Shermans were built so that almost any trained soldier could operate them with minimal stress. A small detail that had enormous consequences for crew performance during long, exhausting battles. German reports increasingly warned that American tanks were not individually superior, but collectively overwhelming. And this collective power came directly from U.S. industrial methods that favor quantity, ease of repair, and battlefield endurance over complexity. And as German engineers continued to analyze these machines, some of them began to admit, reluctantly and privately, that Germany had fundamentally misjudged the nature of industrialized warfare, believing that technical brilliance alone would compensate for shortages in manpower, fuel, and materials. A belief that crumbled as Allied armor rolled across Europe in numbers the German command could scarcely comprehend. By 1944, the dramatic shock among German specialists had turned into a grim acceptance. The Americans were not simply building tanks. They were manufacturing victory itself, using an industrial strategy that Germany could not match. Driven by an economy that operated on a scale so vast that no amount of precision engineering could counter it. And when the final battles of the war unfolded, German tank commanders found themselves facing not individual opponents, but an endless tide of standardized, repairable, resilient American machines supported by supply lines that stretched back across an entire ocean. Machines whose very existence told the story of a nation that understood war not as a showcase for mechanical perfection, but as a brutal contest of numbers, endurance, and the ability to keep fighting day after day without stopping. In the end, when German engineers reflected on what had happened, many recognized that the true shock had not been the Sherman's armor or gun, nor even the staggering production numbers, but the revelation that American industry had rewritten the rules of modern warfare, proving that the future belonged to nations that embraced mass production, standardization, and strategic logistics. A lesson learned too late for Germany, and one that would shape the world's understanding of armored warfare for decades to come.